In this series of videos, we are taking a look at one of the most important programming paradigms in use today, Object-Oriented Programming, or OOP for short. In this video, we look at the concept of encapsulation. Encapsulation is the concept that attributes of an object are protected and can only be accessed or altered via the methods provided by the class. This is a very important concept in OOP. It allows you to totally protect and make safe the data associated with each object. It can't be accidentally altered by another part of the program without using the code you provide. Thus, this keeps you, the programmer, in control. As you can see from this diagram, other objects, that is, instantiations of a class, are prevented from directly accessing the data or attributes inside an object, other than by going through or using the methods that are provided. In OOP, we use the keyword private to show that the following attribute or method is only accessible from within inside the class. You can think of it a little like the use of local and global variables from procedural programming languages that you're more familiar with, but try not to get the concepts too confused. Any attempt to access or change a private attribute outside of the class will result in an error. The method must be used instead. This of course now means that we must make sure to provide a method in the class in order to allow other parts of the program to alter one of the private attributes. This method therefore has to be public. Because the method is public and is inside the same class as the private attribute, it can be called by other parts of the program, and thus it will be able to change the internal private attribute. However, as mentioned before, you now have complete control as you're the one writing the code in that method, which means the attributes can only be changed in the way you specify. Let's put all this into context and look at some pseudocode you might see in exam situations. So here's our person class again that we've been using. We can see there's the two attributes, and as mentioned, the attributes are private, so they can't be directly updated, altered or accessed from outside this class or object once it's instantiated. The procedures, however, are all public, and we have a procedure here for setting the name. So imagine we want to change this internal name attribute. We would call the procedure. So here we say person1 equals new person. We've got a new person object in creation now called person1. We then say person1 dot name equals t. person1 dot name and try and give it t. This is going to generate an error because you can't simply get this person1 object and then directly access and shove stuff into its name attribute. Its name attribute is private, so this causes an error. We have to use the method. So person1 equals new person. We've created a new person object. We say person1 dot set name. We use set name and we pass in our new name and we pass in the letter T. However, look at the code we've written. If the new name dot length is less than 3 or greater than 20, we give them an error message. The name must be between 3 to 20 characters long. So we've now called the set name method of person1 to try and set this name up here, but our code has noted that the input is invalid, and instead of altering the private attribute, it chucks back a friendly error message. So we've controlled access to this attribute. In this final example, we call person1.setName, we pass in Tom. Tom's an acceptable length, and so the local private attribute name gets set to new name, which was Tom.